I was indicating that back in lesson 5.5, it's going to be really important that you understand how to do that. Just when you have to only graph and solve one linear inequality. Because now today in this lesson, our learning goal is I can graph and solve a system of linear inequalities in two variables. So we're going to have more than one solution on a graph. And that was why I was also requesting that you be shading nicely so that we can tell easily. So solutions to a system of linear inequality. System meaning what? What does system mean? This is not hard. We'll make it hard. A system of something in this mathematics world. We did systems of equations. Now we're doing systems of linear inequalities. This means what? Two or more, yeah, just two or more. So more than one, basically. So solutions to these systems of linear inequalities are any ordered pairs making all the inequalities in the system true. So just like with our system of equations, you can't just make one of them true, it has to make both or all of them true. So where would these be located on the graph? Where would we find them on the graph? Well, we would find them on a solid boundary line, just like when there's only one, any point on a solid boundary line surrounding, and this is important, we have to finish it with this, on a solid boundary line surrounding the shaded overlap. On a solid boundary line surrounding, so in other words, it's kind of framing around, it's like the fence, around the shaded overlap. And then the other place would be in the shaded overlap. So where both of them got shaded, all three of them got shaded, however many there are. So we're going to look, we can take solutions for this from the shaded overlap region or from any solid boundary line surrounding that shaded overlap. So we're going to solve y is greater than x minus 4, y is less than or equal to negative 1/2 x plus 2. Okay, I'm going to give you a little picture of what that'll look like by us just like cheating and going ahead and putting it in our graphing calculators first. So go ahead and get your graphing calculators turned on. You go to our y equals screen. Clear out anything that is currently in there. And let's put in our first one, x minus 4. Since these were so nicely already given to us in slope-intercept form. X minus 4. Remember how we give it the inequality? We use the left cursor key and we go over to the left margin, to the left of y sub 1. We want the is greater than symbol. So press the enter key until it gets to the is greater than symbol. It's flashing. And now you can go down to y sub 2. Is greater than, yeah, it's above. So it would be the triangle that looks like it's, you know, I can make one with my hand here. Looks like it's above, not the one below. Okay? Then go to y sub 2 and let's put in, first of all, remember we put in a fraction with parentheses, 1 divided by 2. So we need a negative 1/2 x, a negative 1/2 x plus 2. Negative 1/2 x plus 2, and again we need to go over to the left margin and tell it that we want it to be is less than. These calculators can't do the solid and the dashed line part, but it can do the is less than, is greater than. So go to and make it is less than, which would be the lower triangle one. Press the zoom 6 because it'll give us a nice standard graph. Let's see, let's have a preview of what should turn out when we do it. What does it look like? Can you tell that there's a place where what we would call that shaded overlap? And what does it look like? Where is it right now, basically, we would say any solutions for this system of linear inequalities comes from that region. And then we will talk about, after we get it on the graph ourselves here, how to show which ones can come from boundary lines or not. Okay? So go ahead and just leave that for now. And let's go get ready to do the graphing ourselves here. So we have y is greater than x minus 4. What's the slope and the y-intercept of that one? Okay. So let's go ahead and, again, don't even worry about that other one yet. Do not even worry about that other one yet. Let's get this one totally taken care of before we move on to that other one. So go ahead and get your y-intercept plotted. And using the slope, plot yourself at least 2 more points. And then make a decision, should your boundary line be dotted, also called dashed, or should it be solid? Totally doing this wrong. Start over, look around. One of the things you're going to get out of getting to do, though, is the test point for each individual one. We're going to do check points, test points for our overlap region, okay? So you can graph it. We're hoping that at this point we have learned enough that we're going to get this graphed correctly. So take your pencil and lightly shade for this one. Do not make it messy. Make it nice so that you can tell. Go all one direction. Don't be switching up directions. So we need to shade above this one. So shade nicely above it. Once we have that one done, we can move on to our other one. So go ahead and figure out your M and your B for the second inequality. Get it graphed, making the decisions about dash, solid, where to shade, all that good stuff. When you're shading this one, shade a different direction. Preferably, it makes it a little easier to see. And then after you have done the shading for that one, now you need to look at your graph and you need to determine where is the overlap shaded region. And you need to triple shade that, okay? So find that overlap shaded region and triple shade that. In other words, let's make it very stand out. When we look at your graph, we can tell where the solution region is. And then look at your graphing calculator and see if looks like we did it right. Again, the only thing that we can't tell is the dash and solid line part. Okay? So one of our boundary lines is solid, the other one is dashed. So right now I want you to just give me your attention to understand which ones on the boundary lines count. Okay? So remember I said it can come from the shaded region. I think we could probably pretty easily pick one out from our shaded region. We could name an ordered pair from our shaded region. In fact, let's pick one right now. Let's pick a point from our shaded region that we believe is a solution. Because we have to test 2 points here. So
0, 0.
0, 0. The origin does just so happen to be in there. Okay, so we can test 0, 0. So what we're going to do today is we're going to test ones that actually come from the overlap region. We must test them from the overlap region. And we must test them in both of the inequalities. Has to make both of them true. So we're going to write down our y is greater than x minus 4 and sub into that one, and our y is less than or equal to negative 1/2 x plus 2 and sub into that one. Has to make both of those true. Okay, I ended with 0 is greater than negative 4 for the first one, which is true, right? And I end up with 0 is less than or equal to 2 for the second one. And is that true? That one turns out true also. So since they both turn out true, it appears that I have a good overlap region, a good solution region. Well, I say that we have to give 2 ordered pairs and check. So I want us now to pick one that does not come from the shaded region, but instead comes from a boundary line that surrounds that shaded region. Anybody think they know one we could choose that is actually a solution that comes from a boundary line? Take some negative 1, negative 5. Let me go find that one first of all. Negative 1, negative 5. 1, 2, 3, 4, 5. I shouldn't have used this black on here. I can't see now. Negative 1, 1, 2, 3, 4. Okay, so it's this point right here, right, Tate? Okay. Do you think that one should test true? What did it say though? What kind of a line surrounding the shaded region? A solid line. Is this on a solid line? No. So it would test true maybe for one of the inequalities, but it's not going to test true for the other one. It should test true for the one that I have shaded here with the pink, but it's not going to test true for the one shaded in the yellow because it comes from a dashed boundary line. So let's try another one.
0, 2.
Riley? Negative 2, 2. Negative 2, 3. Okay, negative 2, that would be this one right here. Okay, so it's on a solid boundary line that is surrounding the shaded region, so it should test true. So let's test that one. Test negative 2, 3 in both of our inequalities. Negative 16, that's not true. Negative 6. Okay, the first one I end up with 3 is greater than negative 6. How about you? Yeah. Is that true? Okay, that's true. How about 3 is less than or equal to 3 is what I get for the other one. Is that what you get? Is it true? It's true. Okay. It satisfies the equal to part, doesn't it? And that makes sense that it should satisfy the equal to part because it's on that solid boundary line. That's why it satisfies the equal to part in that one. So we have verified that a solution from the overlap region, a solution from a boundary line that is solid surrounding the solution region makes both inequalities true. Questions on it? Okay, let's go to the back side. And I say, because this is going to happen in your homework, we're not going to practice any, like, physically on our paper here. We'll do some of the graphing calculators just to see. But if the boundary lines are parallel, we're used to, if the boundary lines are parallel in a system of equations, what's true? Is there a solution or not? There's no solution, is there? Because they will never intersect. They will never share any points. But when we're talking about an inequality, now we're talking about a shaded region of solutions. And we're going to have two of them. And so if the boundary lines are parallel, there can be solutions. There's going to be ordered pair solutions when there is overlap. Just like in our last one where they weren't parallel. As long as the shaded region, so when there is overlap, and maybe you should put shading behind that so you don't think that the lines have to overlap. It's the shading that has to overlap. Any part of the shading that you do for each of them would be considered overlap. If there is no overlap, then you get to say there is no solution. So let's go to our graphing calculators. We'll just do a quick test of what that looks like in our graphing calculators, okay? So I want you to put in the following inequalities, okay? I want you to put in y, okay, in y sub 1, I want you to put in x plus 2, and then I want that one to be is greater than. So y sub 1 is x plus 2, and we were going to use the is greater than. Then I want you to go to y sub 2, and I want you to put in x minus 2. And I want you to go and make that one to it is greater than also. Go ahead and press graph, and let's see what we have. Is there any overlap? Where's that overlap at? Between the two parallel lines? Is it not, does it kind of look like a runway? Does it look like a runway between the two parallel lines? Isn't that where the overlap is? No? Okay, can I see? What did I do wrong here? Oh, I'm sorry. It's above the top parallel line, isn't it? I'm sorry. That was my fault. I gave you the wrong text. I was thinking I was using a different inequality. So yeah, so the overlap is above the second parallel line. I guess it goes like this. Above the second parallel line, that one has a solution then, because it has an overlap region. Okay, now I want you to go back to that y equals screen, and I want you to change the second one, y sub 2. I want you to change it to is less than. So y sub 2, we're going to go change it to is less than. Press graph. Is there any overlap? No. So would there be a solution to this one? No, this is one we would get to say no solution to. Okay? Now I'm going to show you what the runway one, how would we get a runway one? Go to y sub 1 and make that one is less than. Go to y sub 2 and make that one is greater than. And graph. Now, all cotton pick and graph should be shaded somewhere, and it's double shaded where? The overlap is where? In the middle, between the two parallel lines. That's what I call the runway one. It's between the two parallel lines, right? Okay, so you're going to be doing some of those types of graphs. We're just not going to practice them in our actual notes that we're doing here. Okay, let's go ahead and turn that off now. Let's go to our last problem, which is write and graph a system of linear inequalities for this situation. At her party, Alice is serving pepper jack cheese and cheddar cheese. She wants to have at least 2 pounds of each, and she wants to spend at most $20, no more than $20. Pepper jack sells for $4 a pound, cheddar sells for $2 a pound. Now we're back to setting up two inequalities, okay? So what do we have? What are we gonna let X represent? Well, go look at the graph, I've already helped you out there. What's X gonna represent? Yeah, pounds of pepper jack, not just pepper jack, pounds of pepper jack. And of course, this is cheese. And then I chose for the y-axis to be what? Pounds of cheddar cheese, yes. Not just pepper jack and cheddar, because we could be talking about their cost. We could be talking about how much of them. The other thing that's important is it says she wants at least 2 pounds of each, right? Is that what it said? Or at most? Which one was it? At least. Wants at least 2 pounds of each. And wants, what else? What's the other stipulation? Yeah, wants to spend at most, so in other words, wants to spend no more than $20. So all of those things are important. Okay, what's one inequality we could set up? Benton?
4x plus 2y is equal to more or less than $20 or 20.
Okay.
2y.
2y, I'm sorry. Thank you for catching that. So, amount of money spent on pepper jack cheese because it's $4 a pound at X number of pounds, how much you'd spend there, plus the amount of money spent on cheddar cheese at Y number of pounds times $2 for every pound should be no more than $20. Okay? Let me give you a little hint. There's actually 2 more inequalities we need to set up. Wants to have at least 2 pounds of each. It doesn't say a total of so many pounds. It says at least 2 pounds of each. Anybody think they know what we could do? Pounds of pepper jack, at least 2 pounds. Pounds of cheddar, at least 2 pounds. Okay, so we need, this one we're going to have to get put into slope-intercept form, so we'll come down here and do that. Okay. This one, what kind of a line is that? X is greater than or equal to. What kind of boundary line will that one have? It'll be solid, but what kind of line will it be? Doesn't have any y's in it. What kind of line does not have any y's in it? The one that crosses the x-axis. Vertical. This is going to be a vertical boundary line. Vertical, solid line. How about this one? Doesn't have any x's in it. What kind of line is it going to be? Horizontal. And it needs to also be solid because of the equal to. Okay, you know what? Before we even get 4x plus 2y is less than or equal to 20 put into slope-intercept form, let's go ahead and graph those vertical and horizontal solid lines. So the one that is vertical has to cross the x-axis at 2. So I go to 2 on the x-axis. Oh, I got to finish numbering this. U2. Get it numbered, labeled. So now I'm ready to go draw my solid vertical line that should not go below that 2 because you can't have negative pounds of cheddar. And then I can decide which way I should shade. X is greater than 2. Which way should I shade that one? To the right. Yeah, greater, all the numbers greater than 2. So lightly shade going in one direction. that part of the graph. Then you can go and draw yourself your horizontal solid line at crossing the y-axis at 2. And again, it would be undo that. Again, it would be a ray because we don't want to extend back into negative territory or pepper jack cheese. And that one says y is greater than, so where should I shade? Above. So now you're going to take your pencil and turn going the other direction, and you're going to shade above that one. Don't be getting too dark yet because you got another line to grab on here yet. Lots of shading going on here. Okay, and then the last thing we have to do is get this one slope-intercept form. So go, get that done. You can do it. Okay, now we have to be really careful before we start graphing this one because we got to pay attention to our scales. The x-axis goes by what? Half a pound at a time. The y-axis goes by how much? 1 pound at a time. So when I say that my slope is -2, and I'm going to put that over 1, first of all, am I going to want to go down 2 and over, or should I? I'm going to start at 10 first of all. So let's go to 10 on the y-axis and put our first point. So I can go down from there. So if I'm going to go down 2 though, when I go down 2, I'm going down to what? 2 pounds of cheese. And then when I go over 1, am I going over a whole pound of cheese? I'm only going over a half a pound. I need to go over a full pound. So when I'm making points for this one, I have to go down 2 pounds at a time and over 1 pound at a time. We have to be really careful that we're plotting that correctly. Not down 2 over 1, but it turns out to be down 2 over 2. Down 2 over 2. This is one I would make lots of points on it, so you get a good line. And this one would be a line segment. And it would be solid because we have the equal to bar. And where would we be shading this time? Below. New shading going on. Now we're going to shade below. Where does the overlap region turn out at? Yeah, I'm going to draw green around it. This is where you should quadruple shade. You should have your 4th shading going on in it. You have this triangle right here that should be darkened on your graph. This triangle right here that I have as green should be our solution region. And then I'm going to leave for you to do for Monday. Give 6 possible combinations of cheese that she could buy. Okay? Anyone have any questions? I know we're running out of time, but that's your focus should not be the time. It should be making sure you know what you're doing.